In physics, a quantum is the minimum amount of any physical entity involved in an interaction. Behind this, one finds the fundamental notion that a physical property may be quantized, referred to as the hypothesis of quantization. This means that the magnitude can take on only certain discrete values. A photon is a single quantum of light as well as all other forms of electromagnetic radiation and can be referred to as a light quantum. The energy of an electron bound to an atom is quantized, which results in the stability of atoms, and hence of matter in general, as incorporated into the theory of quantum mechanics. This is regarded by physicists as part of the fundamental framework for understanding and describing nature, etymology and discovery. The word quantum comes from the Latin quantis, meaning how much. Quanta, short for quanta of electricity, was used in a 1902 article on the photoelectric effect by Philipp Leonard, who credited Hermann von Helmholtz for using the word in the area of electricity. However, the word quantum in general was well known before 1900. It was often used by physicians, such as in the term quantum satis. Both Helmholtz and Julius von Mayer were physicians as well as physicists. Helmholtz used quantum with reference to heat in his article on Mayer's work, and indeed, the word quantum can be found in the formulation of the first law of thermodynamics by Mayer in his letter dated July 24, 1841. Max Planck used quanta to mean quanta of matter and electricity, gas, and heat. In 1905, in response to Planck's work in the experimental work of Leonard, Albert Einstein suggested that radiation existed in spatially localized packets which he called quanta of light. The concept of quantization of radiation was discovered in 1900 by Max Planck, who had been trying to understand the emission of radiation from heated objects, known as blackbody radiation, by assuming that energy can only be absorbed or released in tiny, differential, discrete packets he called bundles, or energy elements. Planck accounted for the fact that certain objects change color when heated. On December 14, 1900, Planck reported his revolutionary findings to the German Physical Society, and introduced the idea of quantization for the first time as a part of his research on black-body radiation. As a result of his experiments, Planck deduced the numerical value of h, known as the Planck constant, and could also report a more precise value for the Avogadro-Loschmidt number, the number of real molecules in a mole and the unit of electrical charge, to the German Physical Society. After his theory was validated, Planck was awarded the Nobel Prize in Physics in 1918 for his discovery beyond electromagnetic radiation. While quantization was first discovered in electromagnetic radiation, it describes a fundamental aspect of energy not just restricted to photons. In the attempt to bring experiment into agreement with theory, Max Planck postulated that electromagnetic energy is absorbed or emitted in discrete packets, or quanta.